We have already argued a bit about using tensile strength to determine the robustness of a structure. However, structure designs based on a calculation that strictly or exactly satisfies the tensile strength have no margin. Here, I am going to explain about safety factor. In reality, design of structures which are exposed to various environments need some margin. In general, we may somehow predict maximum loads and stresses that may be applied in a certain environment. However, there are many cases where loads and stresses exceed the predicted values. For example, an impact load may be suddenly applied unanticipatedly. So, normally, margins for safety is defined in structure designs by setting allowable stress lower than actual strength. Now, let's look at the equation related to allowable stresses. The design strength is the values given as tensile strength, yield stress, and proof stress. You may set the allowable stress at the very edge of the design strength, but it would be dangerous. So, we should set the design strength as a value lower than the strength. For example, if the design strength is 400 megapascal, the allowable stress may be defined as 200 megapascal. Here, the ratio of the design strength to the allowable stress, which is called safety factor, is then defined. If the design strength is 400 megapascal and the allowable stress is 200 megapascal, the safety factor is 2. You may notice that a design with larger safety factor realizes a safer design. So, what are proper values for safety factors? As for this argument, a safety factor of 3 to 7 is often used. However, this value needs to be changed depending on the environment in which the material or structure is used. A safety factor of at least 3 is often selected for machine parts found in our surroundings. Generally speaking, 3 may be the minimum value for safety factor. For example, for structures exposed to impact loads or used for very long periods of time, double values such as 6 or 7 may be used just in case. Although there is often no clear reason or criterion for determining safety factors, this is a rough explanation to grab the concept of safety factor. However, the safety factors in the aerospace field, which deals with airplanes and rockets, is a bit special. The safety factor in the field is roughly 1.2 to 1.5. In most cases, it is 1.5. Very low safety factor is used compared to the general machines around us. This is because airplanes have to be built very lightly to achieve higher fuel efficiency. If the aircraft safety factor is 6 or 7, the airplane becomes very heavy. As the result, it consumes a lot of fuel, and the price of the airplane tickets becomes 4 or 5 times more expensive. With a design of higher safety factor, many people cannot use airplane as they do now. Then, the airline companies cannot make money as they do now. you can understand that they are using a safety factor of 1.2 or 1.5 as appropriate values to balance the cost and profit. It does not mean that aircrafts are dangerous. Aircrafts are designed using much more precise numerical analysis than most structures. So, aircrafts are guaranteed to be safe even with a lower safety factor. You do not need to worry about the safety of airplanes. However, it is true that airplanes are designed near the margin of material strength. It means that airplanes are designed at lower safety factors, so their flights should avoid bad weather conditions. Flying through storms and typhoons inevitably causes strong winds that cause vibrations. This situation causes large amount of stresses, especially on the wings. Under these conditions, load and stress may possibly exceed over assumed safety factors. For the reason, many airlines cancel their flights in the event of a storm or typhoon at rather earlier stage. You may think this airline is covered. This is not true. You may know that the airlines are taking your safety into consideration and decide to delay the flights to ensure 100% safety flights. On the contrast, you may recognize that an airline that flies without hesitation in such storm or typhoon is a bit dangerous. By the way, the safety factor of elevator is about 10. This is a very large value. If the wire hanging the elevator cage breaks, many people are killed or injured. So, an elevator with a capacity of 10 people can actually hold up to 100 people. Of course, you should not do it. Remember, many designs that affect people's lives, like an elevator, have this much of safety margin. Here again, I would like to emphasize that safety factor is a very important concept in the design of mechanical structures. Now, let's challenge a simple calculation. There is a mild steel round bar with a diameter of 10 mm. We assume that the reference strength, which is tensile strength, of this round bar is 400 megapascal. Suppose the safety factor is 3. Calculate how much is the maximum allowable stress and tensile load of this round bar. Since the safety factor is 3, we need to calculate the allowable stress with respect to the reference strength. Then, we calculate the tensile load with respect to the allowable stress. This procedure, which is not that difficult, gives you the answer. You will find the value of the allowable stress and tensile load is 133 megapascal and 10 kilonewton, respectively.